Looking at the derivative of secant inverse of x. So as usual, we'll start off with let secant inverse of x be equal to y, or y be equal to that, and we are taking secant on both ends, and we'll end up with secant of secant inverse of x, which is equal to secant y. So we know that any operation, the inverse of that, if you have in this manner, that is composition of a function and its inverse, we'll get back the output itself. Then we will have to take the derivative of above equation with respect to x. So as usual, this is 1 and this is, what is the derivative of secant of anything? Correct, secant of y into tan of y, and we have y also. As per chain rule, I need to write dy by dx. A bit of rearrangement, and we have y prime is equal to 1 by secant y into tan y. So we know that secant y is x, but what is tan y in terms of secant? Let's substitute tan y as root of secant square y minus 1. So this will be y prime is equal to 1 by secant y times of root of secant square y minus 1. So let's substitute secant y as x, right? That's what we started off with. And so your y prime will be equal to 1 by x root of x square minus 1. And that's your final expression. So here too we'll figure out the domain. That is important for us because, well, without knowing what input can we give, how can we expect us to understand the function? So in this case too, we need to have x, right? X can't be 0, and root of x square minus 1 will always give us a positive result. So it has to be greater than 0. Now, bit of squaring and all of that, we end up with the following. And using a plus b into a minus b, so we'll end up with x plus 1 into x minus 1 greater than 0, right? Because of the identity a square minus b square. Now we have two different cases. See, I have to multiply two things to get a value which is positive. I can do it in two different ways. Let me do this. Case 1, when both expressions are positive, that is x plus 1 should be greater than 0 and x minus 1 should be greater than 0, right? Positive into positive will give me a positive answer. Okay, let's solve this. So x should be greater than minus 1 and x should be greater than 1. So from this, what can I infer? See, both of this condition has to be satisfied. So we have done such questions previously, not this year though, but yeah. So to make sense out of this, let me draw a number line. So we have minus 1 and we have values which is greater than 1. So minus 1 is from here till infinity and plus 1 is from here till infinity. So both of this, there are two people arguing that I need values which are more than minus 1. And another guy asked me to take values which is more than 1. I need to make both of them happy. So which is the best value to take? both of them will be satisfied for all the values greater than 1. So from this I can infer that x should be greater than 1. Similarly, I have case 2 when both expressions are negative. Both expressions are negative. So we are looking at x plus y less than 0 and x minus not y, x minus 1 less than 0, because negative into negative will give me positive again. So a bit of simplification, and we have this to be less than 1 and this is less than minus 1, this is less than plus 1. Satisfying both of this condition, we have values x is less than 1, minus 1. Same thing, just draw the number line. You guys will get the picture. Okay, so from 1 and 2, what can we tell? This being 1 and this being 2. So from 1 and 2, x has to be a value that belongs to R other than values which are between minus 1 and 1, including those values. We can't have this as an input, so excluding that we can have any other real number. Okay, so that is what we have derived for your input for this set of expression, right? Okay, and that is what is the input value which will satisfy secant inverse of x also. So that's the funda. Just wanted to revise this. Anyways, pause and derive all the other derivatives, inverse trigonometric functions derivative.